These are your instructions for the lab determining the percent yield of a reaction. And how you actually end this lab, the calculation that you do is percent yield is equal to experimental yield divided by theoretical yield times 100%. This equation, by the way, should be written already in the back of your lab book. You were instructed to do that. However, if you go to Schoology, virtual handouts, it's in here. Should be lab book equations. I just don't know where it is. General course reference, maybe? There it is, lab book equations. There they are. So if you don't have that in your lab book, you'll need to get them in there. There they are, go find them. Okay, so percent yield is equal to experimental yield divided by theoretical yield times 100%. That'll be one of the last calculations, if not the last calculation you do in the lab. Now, before we do that though, many times when you go to do a lab or a reaction, you have one or two, or especially if you have two or three more reactants, one of them will be limiting. You'll do the reaction until one of them runs out and then that reaction stops. We don't have to calculate the limiting reactant in this lab. That's in the next lab, and I'll probably have a set of instructions for it. Okay, when you do that calculation, I always use the first one to get the second one, and after that I use find the limiting reactant with this. So what we are doing is we don't have a limiting and an excess, or we already have a limiting and an excess. We already don't need to find it. This is sodium bicarbonate, baking soda. We're going to weigh out a certain number of grams of that, and we're going to use excess hydrochloric acid. You don't need to report how much hydrochloric acid you're using. Don't include it, try to include it in your calculations. We already know it's excess. We're not going to run out of it. We are limited with this one. Okay, so we are adding excess hydrochloric acid to sodium bicarbonate to get sodium chloride, water, and carbon dioxide. So we're basically manufacturing salt water chemically, is what we're doing. So if you put hydrochloric acid with baking soda, sodium bicarbonate, you'll get sodium chloride and hydrogen carbonate. You could say if you do this, you got a double replacement reaction. Notice that, if you pair up, whoops, I can't do that. If you pair up the H here with this part, you get H2CO3. If you pair the Cl and the Na, you get NaCl. So this would be reviewing what we've done before, a double replacement reaction. However, it doesn't look like one because at the very same time this is going on, the carbonic acid, H2CO3, is undergoing decomposition to make H2O and CO2. So they happen together. It's a decomposition reaction, or a double replacement reaction followed by a decomposition reaction simultaneously. And we have to know the number of grams of this. So what we're going to do is know the number of grams of sodium bicarbonate, predict the number of grams sodium chloride we should get. That's where our theoretical comes in. We can predict that. If you know on the scale how much of this you have in grams, you can do this calculation. Mass to moles to moles to mass to predict exactly how much NaCl you should get. And that is your theoretical. Okay, so how are you going to do this? You are going to take an evaporating dish and a watch glass and get their mass empty. I'll come along and give you some sodium bicarbonate, a few grams. And if you subtract this total mass minus that, you've got sodium bicarbonate. So you can do it all on a scale, measure it before, measure it after, subtract, you know how much that you've got. Now, the reaction is when you put the sodium bicarbonate and the HCl together. You get effervescence. You get fizzing. That's evidence of a reaction. That's the reaction. After it's done, and you put hydrochloric acid aqueous in here, you have salt water. You have made salt water. You're going to put in about 10 milliliters. This is the excess. This is the reaction. And it'll fizz. And I'll have you do that slowly. Basically, you want it, there's a little lip in this with the lid on. You want to pour in a few drops at a time. Let it fizz, let it fizz. After it's done that for a while, and you've got some liquid volume in there that's watered down, you can start adding it a little quicker. You're going to get about 10 milliliters of this acid. Doesn't matter precisely how much you have. It's the excess. So we'll put about 10 in there. If it's not enough to get done, I'll check it. I'll juice it up with a little more concentrated. But that's the reaction. This is not the reaction. Once you have salt water in here, we have to evaporate the water off so you get salt. We go back to the reaction. Sometimes students think this is the reaction because it happens over fire. No, this is drying. This is desiccating. Okay? You're going to make chemically some water, a little bit, and you're going to chemically make CO2, solid. The carbon dioxide gas is going to bubble out. The water is going to be left behind, along with all the water that was in the solution, which is most of it. And that's what we have to boil off. So you boil that water off, the dry salt is left behind. You weigh that and subtract off the empties that you started with, the empty watch glass and the evaporating dish that you started with, and you've got the mass of the salt. Okay? So to dry it out on day later, after the reaction is done, you put this on here, put the flame under it, dry it out. Okay, what's in here is your experimental. When you subtracted, chaos. When you subtracted this here, when you subtracted this minus this, that got your mass of sodium bicarbonate alone, and you put it in here and you do so many grams, and you convert mass sodium bicarbonate to moles sodium bicarbonate to moles sodium chloride to grams sodium chloride, that gives you your theoretical, your experimental, what was in the actual container goes here, and you calculate your percent yield. So real quick, make sure you look at this in your lab book, but you're going to have to find the grams of sodium bicarbonate. You're going to have to find the molar. These are sample calculations. You're going to have to find the grams of sodium bicarbonate by subtracting. You're going to have to find the molar mass of sodium bicarbonate, which is 3 times 16 plus 12 plus 1 plus 23. You're going to have to find the molar mass of sodium chloride, which is 23 plus 35.5. Your theoretical yield of sodium chloride, that's your grams sodium bicarbonate over 1, converted to moles sodium bicarbonate, converted to moles sodium chloride, converted to grams sodium chloride. Your experimental yield is what you get by subtracting this from the empties. And then your last calculation is percent yield. So setting up your lab, it looks like you're going to have about 1, 2, 3, 4, 5, 6, 7 sample calculations. Okay, the first measured data is you got your empty evaporating dish, and then the evaporating dish with the sodium bicarbonate in it. Then you're going to do the reaction by pouring the acid in. Then you're going to dry it out, and then you're going to have dry sodium chloride in here with the evaporating addition 1 class. You subtract these two, you get the sodium bicarbonate mass. You subtract these two, you get the sodium chloride dry mass. Okay? And then this is what your derived data would look like. You got your mass of sodium bicarbonate after you subtract, molar mass of sodium bicarbonate. Okay, you got the molar mass of sodium chloride and the theoretical mass of sodium chloride. So you will use these two, the molar masses, here. So we're going to use your subtraction here, a molar mass to do that step, a molar mass to do that step, the balanced chemical equation to do this step, and a molar mass to do that step. So that's where those three data are used. And then your percent yield. So you should be good to go. So the sample calculations look like this, except you have your steps in there. Got a little bit of time. So when you go to do your, so you can use this before and after the lab. When you go to do the mass of sodium bicarbonate, you subtract the two masses. Word equation, symbol equation, substitute in numbers, and solve. Do the molar mass of sodium bicarbonate. Just add them up. You don't need all the steps of the sample calculations there. Molar mass of sodium chloride. Just add them up. You don't need to do all the steps that time either. Theoretical mass of sodium chloride. Oh, that one you're going to have all the steps. It says theoretical mass of sodium chloride on here. Theoretical yield of sodium chloride there. That's okay. It's the same thing. Theoretical yields are done in mass. They're done in grams. So you would do mass grams to moles to grams. Okay, and then the next step is going to be experimental. So you got your Roman numeral, title, word equation for your subtraction, symbol equation, put the numbers in, and then solve all 6 steps there. And percent yield is the equation we started with. And that should do it before and after.